Hey, welcome to Secure by Design. Fine-grained authorization for RAG applications. My name is Juan, and I'm a staff development advocate here at Auth0. If you want to learn more about securing RAG applications, securing AI applications, or Auth0 in general, make sure that you follow me on social media at BHACMartinez. Now, before we get into our presentation, let's make sure we cover the legal basis here. So this is the safe harbor. You may have seen this slide before from some of the other sessions here at DevDay, but I need to tell you, this presentation may contain forward-looking statements, and some of the things that you're going to learn here today may be subject to change as we move towards general availability. With that covered, now let's get started. All right, so before we start talking about securing RAG applications, we need to cover a little bit the basics so we all have the same level of understanding. So when we interact with a chatbot, like for example, ChatGPT or Gemini or Claude or any other, there's usually the way where the user starts with an input or a question, and then the LLM will process the result. And the way this works is, for example, when the user asks, what are the days that are public holiday this year, it will process that information based on a pre-trained model, and then it will generate an output. Now, the chatbot may not necessarily be aware of my location, and so when it prints the output, it may provide the holiday lists for a region where I'm not in. So, for example, if I'm in Germany and I ask some chatbot like ChatGPT about this question, it may tell me the public holidays that are available in the US, which is not exactly what I was hoping for, which is a big problem that LLMs have, right? So how do they solve this problem? Well, sometimes they do like tool calling, or they provide additional information like your location, so they can be a bit more accurate. But even when you do that, you're still gonna be limited to information that the model has been previously trained on. But what happens if I'm, for example, working on a chatbot to give to all my employees, and the idea of a chatbot is that employees then can interact with the chatbot to, for example, get all the public holidays that are available for my company, which are the public holidays that are available for the employees' country and region, plus some optional holidays that we give to our employees, for example, to rest as wellness days that we all like to enjoy. So the LLM, because it's being pre-trained with information from the internet, has no way to find out about these company-specific policies. But not all is lost. There is a solution for that, and that solution is called context. And context is a way to provide additional information to the LLM to improve its accuracy. And so the way it works now is when the user asks a question, like for example, which are the days that are holiday this year, this is going to be passed to the chatbot. The chatbot will detect the intent to search for holidays this year. So that will trigger a tool call. And in this tool call, it will interact with the HR database. In our particular scenario, it will look for a document where all the relevant holiday days are for that year. And then the tool is going to combine, or the agent is going to combine the information from the user, so the question, plus all this available context, the list of public holidays, and then it's going to generate a nice formatted output that's going to say something like, here are the federal holidays for you, right? And then it's going to give me the result with accuracy, and it's going to get it right this time. And this is actually what we just did, is we created a RAG agent. And you may be asking, so wait a minute, what exactly is RAG? So RAG is a Retrieval-Augmented Generation, and it's an AI technique that combines LLM's generative power together with context and external information retrieval. So exactly what we've seen now in the results. But there's still a problem with RAG applications, because now let's take a look into our chatbot, but let's change the question slightly and see how it's behaving. So now I'm gonna ask the chatbot, this one we just created, can you tell me where the CEO lives? And so it's gonna send this information to a tool. The tool is gonna do the call to the database, to the HR database, and then it's gonna retrieve the CEO's private file information. It's gonna combine the question with the CEO's file. It's gonna send that to the LLM to provide an output, and then the LLM will say, sure, here is the address of the CEO, and then the address is gonna be printed on the screen. That's probably not a great idea, right? If you're gonna be leaking the CEO's information, that's something you probably don't wanna do if you wanna keep your job. So what you need to do then is you need to find a way to implement access control within your RAG application. And what access control simply means is making sure that the chatbot will reply to information or to questions based on the access system. So the information the chatbot is gonna reply to is gonna be based on what the user can access in the system, in the underlying systems. But again, how do we do that, right? Well, this is how our new flow will look like. So we have the question, can you tell me where the CEO lives? And so that's going to trigger a tool call that's going to search for the HR documents for the CEO information. Once we get that list, then we're going to filter that list based on the user's permissions. So if the user does not have access to the CEO's file, then we're going to remove that from the context. And when we pass that information to the LLM, it's going to contain the question, relevant documents that I have access to, which will not include the CEO's private information or personal information. It's going to pass that through the LLM to get the response. And now it's going to tell us something like, I don't really have access to that information, or I don't know the answer to that question. And so now we design a much better application, much more secure, and we are making sure that all the information we are providing through the chatbot is the information that we have access to through the underlying documents. And this is great and this is fantastic, but we need to see what it means in the implementation details, how we can do this, right? So let's get a little bit technical. Every RAG application is a two different process. Is composed of two different processes. The first process is to encode and save the documents so that it can be searchable. And then the second piece is when a user asks a question, how do we make sure that we capture all the relevant documents and that we can pass that to the LLM? Now, on the first part of this document here on the screen, we have the document loading process where we start by loading all the documents from the source database. That can be something like Confluence, can be markdown files in a folder. It can be web pages on the internet, anything that you can get text from and pass it to the next step. And the next step is to generate document chunks. The way we're going to store the information is going to have some limitations in the amount of text we can process at any given time. You know, for example, that LLMs have a context window and you cannot pass more information that is available in the context window. And so what we're going to do is we're going to generate chunks of information. That's going to be chunks of text from the original documents. And then we are going to generate embeddings for those documents. And we're going to store those embeddings into an index database. Now, once we do that, then we can start querying information through the LLM. And the way we do that is we generate a question and we generate the embedding for that particular question and we send that to the vector database. The vector database will find automatically for us all the relevant chunks that have information about that question, about that input text that we sent out. It's going to give us that back. And we are going to take that list of documents or chunks, and we are going to filter out those depending on the user access level. Once we do that, we pass that information to the context of the LLM, and we generate the output as we seen in the simplified version of this chart. And then the user gets a happy answer there. let's go a little bit more into the details and how everything works. And don't worry if it's a little bit complicated. We are also gonna do a live demo today. So you're gonna be seeing all of this in action and through lines of code rather than just me simply talking. All right, but then the question also that comes into your mind is like, so how can we filter the documents based on the user's access control? And this is where these terminologies come in. There are different ways where we can do that. And there are different types of access control. The most commonly known access control system is called RBAC. And RBAC stands for role-based access control, which means assigning permissions to a user based on their role in the organization. So for example, say you have an organization which handles a blog, you may have roles for administrators, roles for editors, and perhaps roles for viewers or readers of the blog. And each one of these will have different permissions. Like for example, an admin can do everything, a reader can only view content, and an editor can view and edit content, but it cannot delete, for example, or it cannot remove. Then we have ABAC. ABAC is attribute-based access control. It's a little bit more granular than RBAC, but it's also very difficult to work with when it comes to user-generated content. And when we are talking about RAG, we are talking a lot about user-generated content. So ABAC is an option, but it's not the most popular or the recommended option for RAG applications. But then we also have a new boy here on the streets, which is RBAC. And RBAC stands for relationship-based access control, and it's a way to assign to user permissions based on attributes of the entity in your system. The way it works is by defining relationships between users or resources and the data. So we are going to have relationships like, for example, a user owns a document, or a user can read a document, or a user can view a document, or a user can view a folder, for example, and then that folder may contain documents. But don't worry, we're gonna take a look more into RBAC next, because that's the actual access control system that we're gonna use moving forward to have the finest level of granularity when it comes to making decisions for our RAG applications. So how can we implement RBAC in our GenAI applications? Well, we can use something called OpenFGA. OpenFGA is a decision engine that makes decisions based on an authorization model, which is a combination of tuples saved in a database and a model. Now, the tuples will provide the relationships between the data. So for example, like we were discussing before, a document belongs to a folder. A user can read the documents in that folder. That's an example of access control, and it's going to define by the model that defines the hierarchies or the relationships, and the data itself that provides the different connections between the data points. OpenFGA is an extremely useful tool. It can be used for GenAI applications, or it can be used for any other systems that you need to build. But when it comes to using it for RAG applications, you may want to check out Auth4GenAI. Auth4GenAI brings Auth0 expertise in authentication and authorization to solve the challenges of securing modern GenAI applications. We provide a set of SDKs for the most popular AI frameworks that will allow you to easily integrate authentication, authorization controls, and of course, securing RAG applications with OpenFGA and Auth0 FGA. Auth4GenAI is built for some of the most popular AI frameworks out there, like for example, Vercel AI, Llama Index, LangChain, GenKit. But if you don't see your framework here on the list, don't worry. If you're rolling your own solution or you're going with another AI framework, you can, of course, plug Auth4GenAI with any solution that you have. But that was enough of me talking. Let's see how everything works in action directly in the code and through a live demo. If you want to follow me in what we're going to be doing today, make sure that you check out the URL here on the screen, a0.2/drag-demo. Check out that repository and follow up the instructions to set everything up. And let's jump into the demo now. All right, so now into my computer, we are here on the terminal, and I already check out and follow the instructions on the README. Make sure that you do that to be at the same pace with me. During the README, it's gonna provide you all the instructions that you need to set up this repository, to set up your FGA account with Auth0. You can register for that for free, and you can use the script as indicated in the instructions to generate sample data so that you can follow up from there. All right, so the first thing that I'm gonna do is I'm gonna run my application just to see how it works. And so I'm gonna run Python main.py. And so we have a user that is asking here, what is the financial forecast for SQL? We find the LLM or the agent finds one relevant document, and then we have a response from the AI where it says, I don't have specific information on the financial forecast for SQL, advanced systems. So basically it's saying, there's no information about forecast. And that's exactly what we want, because right now, the way I have it set up, I have it with a particular user that does not have access to any relevant information. But how do we know about that? Well, let's jump into the code and see how it works. All right, so here in the code, I have a list of files from this project, and the first folder is called docs. If we go into docs, we see two different documents. We have a public document, which contains general information about the SQL Advanced Systems company, a totally fictional company, by the way. And we also have our private document, which contains forecast information for the fiscal year 25. Again, totally fake. Don't worry about any of it. What is important to understand here is that we have a public document that is going to be available for any user, and a private document, which is going to be restricted to certain users. And we're going to see about that later. Then we have a helpers folder. This helpers is simply additional methods that we need to get our agent to work. We're not going to worry so much about those now. We have scripts, which if you follow the instructions on the README, you use the scripts in here to generate all the OpenFGA model and sample data that you need to run this example. And then we have our .env file with all our secret keys and connections here already ready. I have everything here not visible, but believe me, it's that I measure. All right, so let's take a look into our main.py script. This is where all the magic is happening, and this is where everything that is important it is. We are using LangChain and Python for this example. And the first thing we need to define with LangChain is the model for our agent. And it's going to be a very simple model. It's only going to contain a list of messages. So what you typically see on any chatbot. Very simple, very straightforward. Then we're going to have a tool that we call the Agent Retrieve Context tool. It is a fancy name, but it basically, what it's going to do is every time that it's being asked information about a company, it's going to trigger this tool. And this tool in particular will read all the documents from the documents folder we saw before. It's going to create a vector database in memory based on those documents. This is a process that you don't see normally in production, as your vector database should be hosted somewhere and already preloaded with information. But in order to simplify the steps here, we do here everything in memory. And then this is where all the magic is happening. So we create an FGA retriever. An FGA retriever is what the Auth4GenAI SDK for Python is giving us. And it's going to expect two different inputs. The first one is the base retriever, which is our vector database. And the second one is a build query. And the build query is what specifies the relationships that we need in order to get access to a particular document. And so, for example, our user, our object, which is going to be a document based on an ID, and what relationship do we need? And the user will have to contain the relationship viewer to that document in order to be able to get access to responses based on this document. Now, once we have the FGA retriever, that's the only thing we need to use as this step in the process to generate everything for the context. We don't need to worry about creating the vector store. Everything is gonna be done directly by the base retriever together with the build query. And this is gonna give us all the relevant documents from the vector store already pre-filtered by the user access level. Super easy, right? Because it sounded really complicated. Then it's gonna tell us how many relevant documents it found. If we found documents, it's gonna join them all together into a string. That's gonna be our context. And if we didn't find any relevant documents or chunks, it's gonna simply say, I don't have any information for that. Now, if we scroll down a little bit more into the area where we define the agent, we define our LLM step, which is gonna be chat OpenAI. If you wanna use any other provider, you simply need to use the specific node for your provider within LangChain. I know LangChain has built-in support for OpenAI, Anthropic, Gemini, and some of the Llama open source versions. In our case, we're gonna be using here OpenAI, and then we're gonna build the graph. And the graph is gonna be composed by 3 nodes, an agent, which is gonna run the LLM on the first iteration. Then we have the tools, which is gonna contain the tool that we define to search for the document. And then it's gonna have a generate response. And generate response is gonna take the result from the tool processing, so the context, and it's gonna generate an answer based on the user input and the context. And we're gonna see that in just a second. So let's go into the generate response node definition here. And here we have a prompt template that says that you are an assistant for question answering tasks. And then it kind of pass the question here as part of this prompt and the context. And the context is coming from what the tool generated in the previous step. And then it's simply gonna call again the LLM, passing that information, question and context. Pretty straightforward. After we define the nodes, we need to define the edges, and the edges are the way the nodes connect between each other for this graph. So everything is gonna start with the agent that is gonna resolve the first layer through the LLM. Then we're gonna have a conditional edge, defining if we need to do the tool calling and what comes next. And then in case we are running any tools, we are also gonna call the node generate response. Now, this generate response is an optional node. If we didn't trigger any tool call, it will basically not VIP hold, and the agent will finalize at the agent step. Then to run the graph, we simply have the question from the user. We have a user ID in here that we currently have hard-coded, but if you use Auth4GenAI, you will make sure that you are passing the right user that you are capturing from the context and not simply a hard-coded value. This is just for simplification and showing or demoing one feature at a time. And then we have the result where we simply invoke the graph with our list of questions and we print the results. And so now let's see what happens when I switch the user ID from Juan, which we had before that had no access to financial or to the private document, to admin. And now when I do that and I run once again my script, I get, again, the same question: what is the financial forecast for SICO? We found 2 documents this time, not just the public document. Now we found 2, and now we get a proper response. And the response is the financial forecast for SICO, blah, 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 is bearish with some growth expected around 2-3%. It doesn't matter exactly what the answer is. What is really relevant here is that our agent now was able to identify the different access level between the 2 users, and found the different context levels between like 1 document or 2 relevant documents. And so everything is working as we expected. But we talk about OpenFGA and we talk about Auth4GenAI, but we haven't seen exactly where all this access control data is coming from. So let's jump now into my browser application. Here we are again into my Auth0 FGA dashboard. And when I set up the instructions from the README file and I generated and I ran the script, the setup script, I created a model, and that model defines the relationships between a user and a document, where a document can be owned by a user or a document can be viewed by a user. And this is what we define the model here. But then it also set up some data for us, and that we can see here on the tuple management on the screen. We have our user. In this case, we're using a wildcard. So any user can have access to the document, public document, as a viewer. And then the user admin can also access the private document as a viewer. And these are the two relationships that we built that allow us to make the distinction when we run our agent here on the screen. So that's how everything comes back together. All right, so that was it for today, folks. That was the demo that we had for building a secure RAG application with Python here today. I really want to thank you for watching this session today. Make sure that you check out the rest of the sessions here at DevDay. Tons of exciting content. If you want to learn more about Auth0 and Auth4Gen AI, make sure that you check this QR code here on the screen. And with that said, I leave you all for today. Hopefully you learned something and keep enjoying the rest of DevDay. Thank you.